Example 5 is talking about average rate of change for a function over a specific interval. Um, Average rate of change is really going to refer to the change in y over the change in x. So let's take a look at this example. So the first thing you're going to look at, so if we're talking about the interval from a to b, the first thing you're going to do is figure out what are the order pairs. So if it's asking for x values of a and b, you need to figure out what is f of a, which would be like your y value. So the next thing you're going to figure out is what's the total change. So that's just the change in the y value of the b function compared to the change in the function, the value of the a function. The interval length is the difference between the x value for the b and the x value for the a. And your average rate of change is just going to be the change in the y over the change in the x. And that would end up being that purple line there. This is going to make more sense when we actually use real numbers, I promise. All right. So what do the average rates of change over the intervals -2 to 0, 0 to 3, and -2 to 3 indicate about the given functions? Okay, so let's look at the first one. The first function is just f of x equals 1. So it's just y equals 1. It's a horizontal line. So you've got your points -2, 1, 0, 1, and 3, 1. All the y values are 1 because it's f of x equals 1. So for -2 to 0, for that first interval, from -2 to 0, the slope is 0 because it's a horizontal line. From 0 to 3, so from here to here, the change is 0. All right, the slope is 0. Essentially, that's all you're doing. It's change in y over change in x. All right, and then from -2 to 3 for the entire thing, it is still 0. The slope is still 0. So f of x equals 1 has the same rate of change, 0, over every interval. This means it is a constant function. Okay. Let's look at g of x. This is g of x is equal to 1/2 x minus 1. It's a line, okay, but it has a slope to it. So from -2 to 0, you've got change in y over change in x, and the slope is 1/2. Okay. From 0 to 3, again, change in y over change in x, the slope is 1/2. From -2 to 3, the change in y over the change in x is also 1/2. So that function has a constant rate of change, and it is 1/2. So that means it's a linear function. All right, linear functions have a constant rate of change, and that constant rate of change is the slope. You could have figured that out just by looking at the equation, by the way, because the coefficient of x is going to be your slope. Let's look at this. This is a quadratic function. H of x is equal to x squared. So the average rate of change between -2 and 0, again, change in y over change in x, is -2. The average rate of change from 0 to 3, change in y over change in x, is 3. And then from -2 to 3, the change is 1. So h of x equals x squared does not have a constant rate of change, and this means it's not a line. It's not a linear function. All right, so at this point, I would pause it, give it a try. By giving it a try, I mean figure out what's the constant rate of change, what's the rate of change over the 3 intervals. Okay, um, so try that, and then determine if it's a linear function or not. All right, so pause now. Okay, so let's do it interval by interval. I'm going to write on the screen here. So from -2 to 0, we first need to figure out what are the y values. So when x is -2, what's the y value? We're going to substitute -2 into the function. So y is equal to the absolute value of -2, because -2 is the x value. We're figuring out what the y value is. Absolute value of -2 is 2. 2 plus 2 is 4. All right, so you've got the ordered pair -2, 4. Um, now we need to figure out what is the ordered pair where x is 0. We're going to do the same thing. So y is equal to the absolute value of 0 plus 2. Absolute value of 0 is 0, so y is equal to 2. So the ordered pair would be 0, 2. So the rate of change is going to be, the average rate of change is going to be the change in y. So 2 minus 4 over 0 minus -2, so 0 plus 2. Okay, and then that equals -2 over 2, which is -1. Okay, I'm going to do the same thing from 0 to 3. Well, we already know the ordered pair at 0, so now we just need to figure out what is the ordered pair at 3. So when x is 3, what's the y value? I'm going to substitute 3 in for x like we have before. So y is equal to the absolute value of 3 plus 2. Absolute value of 3 is 3, and 3 plus 2 is 5. So the ordered pair would be 5. So again, this answer was from -2 to 0. The second one's going to be from 0 to 3. So from 0 to 3 is we're talking about this point and this point. So 5 minus 2 over 3 minus 0. So you end up with 3 over 3, which is 1. So at this point, I already know they're different. So I know this isn't a line. Well, I kind of knew it wasn't a line because it was an absolute value function. But there, that confirms it. And last one is asking me to find the average rate of change between -2 and 3. So that would be this point and this point. So it's going to be 5 minus 4, change in y, over change in x, 3 minus -2. So 3 is 2. So you end up with 1 over 5, 1/5. So what does it indicate about the function? It's nonlinear. Okay, so since the rate of change changes over the 3 intervals, that equation is a nonlinear function. Okay. Now we have a concept summary.